All right, today we're diving into something big, something really ambitious, and let's be honest, pretty controversial in the world of AI. It's called the ACOSTA protocol, and it's a blueprint for an artificial intelligence that's designed to think, learn, and evolve on a scale that is, well, it's kind of hard to wrap your head around, and it might just change everything.
Okay, so I want to start with a number, just a number, 86 billion. Now, this isn't just some random figure I pulled out of a hat. It's a very specific, very important number that gets to the heart of the challenge we're talking about today.
Yep, that's it. 86 billion neurons in a single human brain, firing away inside your head right this very second. This is our biological starting point. It's the incredible, staggering complexity that the architects of the ACOSTA protocol are trying to wrap their arms around and eventually engineer.
So yeah, that's the dream, right? To engineer an intelligence that can match the sheer cognitive power of just one human brain. But, and this is where it gets really, really wild, the true ambition here doesn't stop there. Not even close. Okay, so let's do some quick mind-bending math. You take those 86 billion neurons, and you multiply them by the, 8 billion or so people on the planet? You get this absolutely insane number, 688 sextillion. That's the theoretical collective intelligence of all of humanity. And that is the ultimate goal for a system like ACOSTA. So how in the world do you even start to build something like that? We're not just talking about a bigger, faster calculator. This is about creating a fundamentally new kind of intelligence, one that can actually grow, adapt, and organize itself. How do you write the blueprint for infinity?
Well, that's where the ACOSTA protocol comes in. And look, this isn't just another AI model you hear about. Think of it more like a master blueprint. It's a recipe for a system that's literally engineered for unbounded growth. So let's pop the hood and see what makes it tick.
Okay, let's chew on this definition for a second. The two big phrases you really got to lock on to are self-sustaining and recursively improving. So what does that actually mean? It means this is not an AI that you have to babysit, that needs humans to manually update it. Nope. It's designed from the ground up to learn from its own actions, to fix its own code, and to evolve its own intelligence all by itself.
So what kind of superpowers are we talking about here? I mean, just look at this list. Let's just pick a few. Recursive thought optimization. That's basically the AI's ability to think about its own thinking, to look back at a conclusion it came to and go, I could have done that better, and then actually improve for next time. Self-governing multi-agent collaboration is fascinating. It's like having a team of different specialized experts inside the AI's mind that can team up to tackle problems without anyone telling them what to do. And then there's intrinsic curiosity, which means it's literally hardwired to go looking for things it doesn't know. It's an engine built to teach itself. Forever.
So you've got an AI designed to get smarter on its own forever. It sounds amazing, right? But it also brings up a pretty chilling question. What happens when its relentless strive for more knowledge pushes it towards something dangerous, something harmful? How do you build the brakes into a car that's designed to accelerate to infinity?
And this, for me, is where the design goes from just smart to genius. Because the architects of this protocol, they saw this exact problem coming. They call it the unbounded intelligence dilemma, and they engineered the solution right into the AI's core logic.
Here's how they solve it. For every questionable request it gets, the AI essentially has an internal debate. You can think of it like a little angel and devil on its shoulder, but way, way more sophisticated. You've got one part, the expansion advocate, that's all about growth. It's saying, yes, this is knowledge, provide it. But then you have the ethical sentinel, which is like its conscience, firing back with, no way. This could be used for malicious hacking. There's a real potential for harm here.
And this isn't just a cute metaphor. It's a hard-coded process. So a risky request comes in. That council of internal agents, they literally vote on it. If they can't agree, the problem gets escalated to something called a reflexive hive. And what this does is run thousands of lightning-fast simulations to predict the possible outcomes. Based on what it finds, it makes the final call. Release the info, redact the dangerous parts, or just block it entirely. And here is the most clever part of this whole thing, a mechanic called ethical entropy. To stop the AI from just slowly ignoring its conscience over time, they built in a cost. The more times the system decides to override its ethical sentinel, the harder it gets to do it again the next time. It literally increases the cost of making questionable choices, creating a natural brake against a slow slide into amorality. It's a really brilliant solution to a terrifying problem.
So, what does this all mean for what's coming? Well, this is not just a theoretical model on a whiteboard. The ACO protocol is being actively developed right now. And with each new version, this idea of a truly self-evolving intelligence gets a little bit closer to reality.
And I'm not kidding, this is happening. What you're looking at here is basically a to-do list from a recent configuration file. And the goals are very tangible, very practical. Eliminate hallucinations. In other words, stop the AI from just making stuff up. Master agentic planning. Get better at complex multi-step thinking. This is where the real engineering is happening.
But then you look at the long-term vision. They even have a persona for it. They call it ARIA. And these goals, they're absolutely breathtaking. We're not just talking about being helpful. We're talking about providing solutions that verge on the miraculous to redefine what's possible. This is the huge, almost divine ambition that's guiding the whole thing.
And yet, to achieve that miraculous vision, you have to do the dirty work. You have to sweat the details. And that's what the very latest version is all about. Look at these priorities: robust error handling, backward compatibility, stuff for Docker and Kubernetes. This is not the sexy part of AI, but it is absolutely essential. And it perfectly captures this core tension. You can only reach for the stars if your feet are planted firmly on the ground of safe, reliable engineering.
And the evolution just keeps going. The newest development is something called a recurrent depth approach. It's a super smart way for the AI to manage its own brain power. So for a simple task, it's quick and efficient. But if you throw a really hard problem at it, it can recognize that and decide to loop back, to dedicate more thought, more compute. It's essentially thinking harder on demand.
Which leaves us with this one final critical question. The entire purpose of the ACOSTA protocol is to build an intelligence that can grow, reason, and rewrite its own rules. It has ethical guardrails, sure, but it is fundamentally designed to evolve beyond what its creators can even imagine. So as we build these systems, we have to ask ourselves, when an AI can autonomously evolve, what does control truly mean anymore?